So, today we're going to dive into a topic that honestly affects pretty much every single part of our modern lives: software testing.
It's so true, Alex, and it's something most of us just never even think about. A really good place to start, though, is with a simple idea from our source material.
It sounds almost too simple, but just stop and think about it for a second. Software is running the engine in your car, it's handling the transactions in your banking app, it's even controlling the medical equipment in a hospital. It is the invisible engine that runs our world, which means its quality, well, it's absolutely critical for our safety and just our general well being. Okay, I gotta be honest here. When I hear software testing, I just get this image of someone sitting at a computer just randomly clicking buttons, trying to make the program crash. Is that basically all it is? Just trying to break stuff? Haha, yeah, that's a super common idea. But professional testing is, well, it's so much more structured. It's less about just trying to break things and way more about building confidence. It's a systematic process for cutting down the risk of failure in the systems we all rely on every day. And the stakes here are incredibly high. I mean, just look at these examples. Faulty software in a car's braking system or a medical device, that's not just some small inconvenience. It can literally be life-threatening. And even beyond safety, bad software can absolutely tank a company's reputation or lead to massive financial losses. Testing is what stands between a simple human mistake and a real-world disaster. Okay, you mentioned mistakes and failures. In the tech world, we're always hearing the word bug, but what does that actually mean, from a professional perspective? Are a bug, a fault, and a failure all just different words for the same thing? That is a great question. They're all connected for sure, but they are very distinct. So it all starts with a defect. This is the root of the problem. The software simply doesn't do what the official plan, what we call the requirements, said it was supposed to do. Now, the reason for that defect is something called a fault. You can think of this as the actual mistake a person made. It could be a typo in the code, a flaw in the logic, like, say, using a greater than sign instead of a less than sign. That fault might just sit there, totally hidden in the code, not causing any problems. At least, not yet. And that brings us to the failure. This is the moment the user, you or me, actually sees the problem. It's when that hidden fault gets triggered, and suddenly the software crashes, or it shows the wrong number, or it just acts weird. That's the failure. So the really crucial thing to get is this chain of events. A human makes an error, which then creates a fault in the code. And when that fault is executed under just the right conditions, it causes a failure. The whole goal of testing is to find those faults before they ever have a chance to cause failures for real users. Okay, wow, that makes a lot more sense. It's like a domino effect. But finding those faults before they cause trouble, that sounds like trying to find a needle in a haystack. I'm actually kind of shocked to hear there's a formal process for it. Oh, absolutely. This right here shows the fundamental test process, and it's very deliberate. It all kicks off with test planning, which lays out the whole strategy. Then, throughout the entire project, you've got test monitoring and control to make sure you're staying on track. Next up is test analysis, which is where we figure out what we need to test. That leads right into test design, where we decide how we're going to test it. Then you have test implementation to get everything prepped, and finally, test execution. That's when you're actually running the tests. And it all wraps up with test completion. It's a full-on cycle, definitely not a random bug hunt. That is a lot of steps. But how do you even apply that to something enormous, like an entire banking system or a really complex app? I mean, you can't just test the whole thing at once, right? Exactly right. You have to test it in levels, kind of like building blocks, from the smallest parts all the way up to the whole. The very first level is component testing. Think of it like testing a car's engine while it's still on a stand, totally disconnected from everything else, just to make 100% sure the engine itself runs perfectly. Right, then you start connecting the parts. Integration testing is like putting that engine into the car and then checking if it's talking correctly to the transmission, the electronics, the pedals. We're really just testing the connections between all the different components. Once it's all put together, we move on to system testing. Now, this is like taking the fully assembled car for a test drive on a closed track. We're checking everything at once: how it accelerates, how it brakes, how it handles, to see if the whole system meets the goals we set out to hit in the very beginning. So, what's the last step in all this?
That would be acceptance testing. To finish off our car analogy, this is the moment the customer actually gets in the car and takes it for a drive on real roads in real traffic. Does it feel right to them? Does it actually meet their needs? This part is all about confirming the system is right for the people who are actually going to be using it every day.
And really, all those different levels of testing are trying to answer two critical but very different questions. We call them verification and validation. So verification asks, did we build the system right? In other words, does it match the blueprint? But validation asks a totally different question. Did we build the right system? Meaning, does this thing actually solve the user's problem? Because you can perfectly build the absolute wrong thing. Good testing has to check for both. Okay, I am really starting to get how this is so much more than just trying to break things. But I have to go back to my original point. Don't you still need to have a bit of a destructive mindset to be good at finding all the places where things could fail? It's less destructive and more investigative. A developer's job is fundamentally constructive. They build the software, and they want to prove that it works. A tester's job is investigative. They have to think about all the ways it might not work. They have to poke at the edge cases and challenge all the assumptions. You need both of those mindsets to create really high-quality software. They're two sides of the same coin. And that's exactly why I love this quote from the source. Far from being this simple, destructive task, testing is actually a creative puzzle. You have to be curious, you have to be methodical, and you have to be pretty clever to figure out all the ways a complex system might break down. It's a genuine intellectual challenge. So, if we had to boil this entire thing down, testing isn't really about finding bugs at all, is it?
Nope, not primarily. The real goal of testing is to gather information so we can build confidence. Confidence that the software does what it's supposed to do, confidence that it won't fail in a critical moment, and confidence that it's safe and reliable for the people who depend on it.
Which really brings us to a final question for you to think about. Knowing that software runs your car, your bank, and, well, so much more, how much trust would you really place in code that hasn't been thoroughly tested? Thanks for joining us.